Okay, now we want to find roots other than square roots. So there's a couple of ways to do that in your calculator, and I'm going to talk you through it. Okay, on the TI-83 or 84, what you want to do is hit Math, and then when you look at that, you're going to look for the number, which should be what's right there. You want to find the cube root. These are all cube roots because the index is 3. So one of the options says this. That would be the option that you would want to use. I think it's option number 4, but I'm not 100% sure. I don't have my calculator with me. So look under, when you hit the Math button, look for this that says cube root. And so what you're going to put in is that, and then you're going to put the number in, 1000, close the parenthesis, and then hit enter. Okay? So put in 3, the cube root there by hitting Math, cube root, put in 1000, close the parenthesis, hit enter. You should get 10. Because this is an even root, you don't put plus or minus, because when you multiply something together 3 times, remember it's either just going to be positive or just going to be negative. So we want to make sure it's positive. It's a positive number under the radical, therefore it will be a positive root when you take it out. Okay? Cube root of a fraction. Just separate it, the cube root of 1 over the cube root of 27. Remember, this is asking you, what do you multiply by itself 3 times to get 1? Okay, well, that's just 1. What do you multiply together by itself 3 times to get 27? Well, that's 3. Or you can use your calculator, and it's just 1/3 is the answer. Okay, number 13. The cube root of 125. What do you multiply by itself 3 times to get 125? Again, put it in your calculator. You'll find that that number is 5. With variables, recall that you take the exponent and divide it by the root. So 9 divided by 3 gives me a to the third. And now we need to check that even, even, odd rule. Anytime you have a variable, you need to check to see if it requires absolute values. So is it an even root? Well, no, it's an odd root. Immediately you can stop. No absolute value symbols are required. Okay, here's another one of those graphs and domain and range problems, but it has more than one transformation. You'll notice that underneath the radical we have a number, and outside of the radical you have a number. Well, here's the regular cube root function. If you put it in your calculator, you'll notice that it's going to look something like this. It's going to go through the origin, and it's going to go here and here. Okay, so it kind of has a turning point right there at the origin. That's what the f of x equals the cube root of x looks like, a sketch. So now I'm going to change pen colors to blue, and now let's describe the transformations. So remember, if it's under the radical, it's going to move it left or right, and you need to take the opposite of that. So the opposite of positive 2 is negative 2, and the negative direction for left or right would be left. So the transformation is left 2 units, because you take the opposite, that makes it negative 2, which means to the left 2. The number on the outside tells you whether it's up or down. You do not take the opposite here. You simply go the direction of the sign. Since it says positive 3, that means up 3 units. So your transformation from this graph is to move left 2 and up 3. So you pick a point. I always pick this inflection point here. This is where it turns here. And I'm going to move that point left 2 and up 3. So that inflection point is going to be right here. And then remember, you're going to go up this way and down this way. And that's what the cube root's going to look like as the transformation. The center point moved left 2 and up 3. Okay, so now you have graphed it. We've described the transformation. We need to know its domain and range. We're looking at the blue graph, domain. Well, you'll see that it has an arrow going in both directions, left and right, so that means we're going negative infinity to infinity. And the range. Notice the range is going up and down, and as you continue left and right, it's going to go up and down. So the range is also negative infinity to infinity. Okay, so now you've done all things that were required. Okay, now we want to do roots other than cube roots, square roots. These are a little harder in the calculator. The steps in the calculator are first put the root in. So if you're going to do problem number 15, you would put 4, then you would press math, and I think it's option number 5, but that option says the xth root. Then you have to put in the parentheses and put 1 divided by 81, close parenthesis, and then hit enter. Okay, so you go enter the root first. So here's the root, which happens to be a 4th root. Math, I think it's option number 5, that's the xth root of, and then you put in the number and hit enter. Okay, that means, in other words, what do you multiply by itself 4 times to get 1? What do you multiply by itself 4 times to get 81? That means 1/3. Since it is a 4th root, an even root, you would have to indicate whether it's the positive or the negative. Okay? Okay, anytime you have 16, an exponent under the radical that's the same as the outside, remember the base doesn't matter whether it's a number or whether it's a variable. You take the exponent, divide it by the index. So this is going to be 10. 5 divided by 5 is to the first power. It's an odd root. It does not require absolute values. 6th root. You can put this in your calculator. How you would change this is that the root would now be 6, math, option number 5. You're going to put the number of negative 64 in and then hit, make sure you put parentheses there, then hit enter. The other thing is you're asking yourself, remember, what do you multiply by itself 6 times to get negative 64? And if you think about it, there is no number that you can multiply by itself an even number of times and get a negative number. So this is not possible, and that's what you would write here. Is you could either write no solution or you could write not possible.